Okay, ladies and gentlemen, let's start our first talk. We've got Randy Mackay and William Galvani with the small aerial photography drones with AP.
Okay, good morning, good morning. My name is Randy Mackay, and I'm the release manager for Copter and Rover. And yes, this is a two-part presentation. So I'll be doing, at the beginning, I'll be doing a little review of my aerial photography copter, and then I'll hand over to William, who will talk more about Blue OS. But before we get into it, I just want to say thanks again to Matt and Peter Hall and 3DXR for hosting this great event, and also to our partners for supporting the conference. Okay, so you might ask, why bother making another aerial photography copter? There's lots of them out there, right? But I'm often asked, where can I buy an RTF copter? And there are many options, but I think what the person asking the question actually wants, or is actually asking, is where can I buy an ArduPilot based drone, which is like a Mavic? And so that it comes with a whole bunch of extra conditions. They want an aerial photography copter, which can record like 4K video. They want real-time video to the ground station. They want it to be easy to fly, not too complicated, at least 30 minutes of flight time. They want a smart battery. They want some kind of object avoidance. They want some kind of cloud integration, maybe automatically uploading files to the cloud, maybe automatic installation of new firmware. And they also want it to be not too scary looking and not too expensive. So once you add in all those conditions, it's actually a really tall order. It's not easy at all. And so I thought that, I've been asked this question for so many years, and I thought this year I'm going to try some of these really hard things that have been hanging around for a really long time. So I thought I would try and make one, and successful or not, at least I will highlight those issues that we need to improve upon. And make it easier for the next person. So this is the hardware I chose. I used a Cube Orange Plus and a Here 4 GPS. Also, I wanted this copter to be use as much of the new technology as we have available in the ArduPilot community. So I wanted it to be Ethernet based. I want the camera, the autopilot, everything else connected via Ethernet if possible. So I used a Cube node to allow the Cube Orange Plus to be able to speak Ethernet. Also, I want a companion computer, so I put, it has an RPI compute module 4 or 5, either one. I'm using AM32 ESCs. So you remember Tridge demonstrated this for the first time, I think, last year at the conference. So it's got those. I use the Vim drones design. So Huibin is right there. He helped me a lot. On his website, he's got an open source AM32 development board. So I use that as the base for my ESCs. We've also got a Quectel LTE modem. The drone can also support HearLink, but in this particular variety, it uses a Quectel modem. The really cool thing about these modems is that there's like 12 different versions you can buy. So I've got the Japanese one normally, but for this conference, I wanted a DigiKey. I ordered a UK version. It totally fits in the drone, and it works. It worked in like 30 minutes. I couldn't believe it. Then it's got an XF Robot Z1 mini camera gimbal on the front. Sorry, I should turn it around. And the reason I chose this one is because it's the smallest Ethernet-enabled 3-axis camera gimbal that I could find. So that's why I chose that. It's got a HearFlow optical flow sensor on the bottom here for low altitude non-GPS. It's got 2 Beniwaki LiDARs. So it's got a downward facing one, the TF20L, and then it's got a forward facing TF Nova. And the reason I chose that, the Nova, is because it's actually got a 14-degree field of view. So for forward avoidance, better chance of seeing the person or whatever. I use the T Motors 400 kV motors. It's a 6S. It has a 6S battery. So the 400 kV motors, MAD 12-inch holding props. And then on the bottom, it fits a Foxtech semi-solid state battery. So semi-solid state batteries, I love them. They're slightly more expensive, but you get more flight time. So if you're competing with, I don't know, some other mass market drone, that's an easy way to get more flight time. Then also, I think what's also quite cool, it's still a work in progress, but a BMS, so a smart battery. This one is also from Vim Drones, and it's got a little, it will eventually be integrated into the battery. That's not done yet, but it's got a little button, and you push the button, and you can see the charge of the battery. So right now, this drone uses XT90s, because that's what the battery comes with, but we're hoping in the future to replace it with a custom battery which has the BMS inside of it, and also easy to connect and disconnect pins. So that's in the works. Oh, also the frame itself. This was designed by Tsuyoshi Arakawa, who works at my company, Japan Drones, and yeah, it's made of two types of. It's 3D printed. The bottom is PA12W nylon. Oh, sorry, ASA carbon fiber on the bottom, printed with a bamboo printer. And then the top part we ordered from a professional company. It's PA12W nylon. That's, so it's a little bit prettier on the top. It's nice and smooth. Better than our printer could make. So that's what I put in there. I'm happy to take questions at any time, by the way. Okay, so I'll get into the hardware a little bit more on a future slide. But before I do that, just want to show that it actually flies. So this is its first test flight about a week and a half ago in my garden. And this is the stock RG Pilot tune, because it is a very standard size vehicle. Now, it's a 450 size vehicle. Totally flies. It's hard to see, but the vibration levels are very low. The EKF is very happy. There's a little bit of barometer interference when the vehicle takes off, probably because we have a fan on the front. We have a cooling fan, and maybe the thrust from the propellers goes into the fan and causes a little bit of interference. But it's actually about 3 or 4 meters of interference, but it's very transitory. EKF just gobbles it up, so it's no problem. So totally flies. Okay, so now I think what's really special about this drone is the custom carrier board. So we had an earlier version of the drone, and we put all the different parts, just regular parts you could buy off the shelf into it, like a drone net, a cube orange on a small carrier board, etc. And it flew really badly. And the big change was when we added this custom carrier board. So I developed this with a company called Running Electronics in Japan, and it's got all the parts that I talked about earlier. The pins are in the perfect place, so that previously it was a mess. I don't have a picture, but the wiring was a mess in the earlier version. With the custom carrier board, all the wires are right near the components that they're connecting to. So you open it up, and it's very nice inside. Also, though, the carrier board really improves the rigidity of the frame. So the vibration levels drop down to very good levels, and it flies much better. Also, these mass market drones, the reason that they're so cheap is because you can manufacture a whole ton of them, and it's really easy to manufacture them. So having a carrier board in there makes the assembly and the build much faster and much easier, and therefore much cheaper. It also saves on weight and cost, I believe, because you're not paying a profit margin to every single component manufacturer. Instead, suddenly you are the manufacturer of many of the parts. So like the ESCs, the switch, etc. All of those things are suddenly manufactured in Japan locally. So sure. Another nice thing about the custom carrier board, we put all the hot components on the bottom. So the ESC and the Cube node and the Raspberry Pi in particular, those all get very hot. So we put that on the bottom, the autopilot's on the top, and the fan blows over the bottom only. So it doesn't affect the barometer, but it keeps all those other components cool. And so there's a little fan controller right on the front here. Oops, sorry. Little fan controller. It turns on and off the fan. Right now it's manual, but I'll add a Lua script. So when the components get hot, it automatically turns on or off. So that's that. Cool. Okay. Any questions? Yes, Jonathan. Oh, wait, sorry. Let's wait for the microphone. Where's the microphone? I'll take a drink.
Citation needed on doesn't affect the barometer.
Sorry, you mean the fan?
The fan.
Yeah, well, as far as I can tell, it doesn't affect the fan.
Okay.
Okay. Sorry, I don't get it. I'm sorry. Was there another question? I think I saw somebody had their hand up. No? Okay. All right, I'll move on, if that's okay. Okay, yeah, so then that was the hardware. Next for the software. One of the things that I mentioned back on the earlier slides about, people's expectations, they expect OTA updates. And so as much as possible, I wanted to be able to update every single component on the drone. So, so this is the software stack I chose for the ESCs, AM32 ESCs connected via DroneCAN. So again, you can update the software without any problems. We also have we have feedback from the ESCs, current voltage, everything, RPM. We can tell when a motor has failed. So yeah, that's why I chose that. ArduPilot in the middle. And that includes, of course, regular ArduPilot 4.7, but then, many of the other components, the Cube node, the Here4 are all AP periph. So yeah, ArduPilot in multiple places on the drone. And then at the top level was BlueOS. And this is one of the parts that I'm most excited about. I obviously saw William's presentation last year about BlueOS. I needed something for the companion computer, so I gave it a try, and I'm really excited about this part. And for me, I'll talk about it a little bit later on later slides, but what's really exciting for me is that suddenly it's like walking into a new room. We have a whole new computer that we can play with. There's all kinds of extensions that we can write that we just could not put on the flight controller. The BlueOS had, well, I should talk about it on the next slide, actually. But there's just so many things that we can do with BlueOS, which I'll get into later. So I'm really excited about that. Here we are. It's right here. Okay. So why is BlueOS a great choice? It already exists. You don't have to make it yourself. It's got a development team behind it, William and the other guys, supported by Blue Robotics, right? Has a real business model there. It's got a large user community already who is helping with beta testing. It supports ArduPilot. Previously it was just subs and boats, but now it can, it's getting better at doing multi-copters. But the next part is the extensions, which I love. So with extensions, which are based on Docker, you can very easily take like any Python program or whatever that you've ever written, and you can roll it out on BlueOS. And you also get access to an interface. So this is my optical flow extension that I wrote in a couple of days with help from Sanket Sharma. Where's Sanket? There he is, right there. So he's one of our non-GPS experts. So he helped me with this extension. But there's a bunch of extra settings that I wanted to put in the extension, like what image quality should I use? What's the maximum number of points that I should use for the optical flow? Anyway, there's a bunch of configuration that I wanted the user to be able to fiddle with. And with BlueOS, you can do that. Your extension can have a front end, and you can put all the little settings, et cetera, in there to make it easy for the user. Also, BlueOS has easy access to Mavlink from the ground station or the autopilot. And it also has easy access to the camera. So, for example, if you wanted to write a BlueOS extension, which took images from the camera. I don't know what you want to do. Maybe you want to identify what's in the image or something. You should have a peek at my precision landing and my optical flow extensions, because they do that. They can grab, frames at 30 hertz, and you can do whatever you want to do with them. Also, the programming has become so much easier thanks to Claude AI and other AIs. I'm mostly a C++ developer. I have not done very much Python or JavaScript, almost zero JavaScript. But even so, I could put together extensions in 2 or 3 days. And just the last thing is just getting back to the OTAs. So BlueOS has built into it, OTA support. So when a new version of BlueOS is available, and you log in, you pull up the web page, it pops up a little message saying, a new version's available. Do you want to upgrade? And you say yes, and it installs the new version. And the extensions are not quite so, they don't have a little pop-up unless you add it yourself, but it is still quite easy. You can go into the extensions screen, you can find your extension and just, pull a drop down and say install, and it'll install the latest version. So it's quite easy to do all that, software management or release management. Any questions? No? Cool. So, how does my copter use BlueOS? I've already talked about it a bit, but it uses it in a number of ways. The first one is the LTE telemetry. So, like I said, this drone can take a HERE link, but this particular version uses LTE only for the telemetry. So BlueOS has a 0-tier extension, which makes it easy to connect to your drone from your PC. It's got this high altitude optical flow extension. So previously for optical flow, we've always had a camera which is fixed to the bottom of the drone, and I'll talk about it on a later slide. But with BlueOS, you have easy access to the aerial photography camera. You can get images off of that easily, so I use that for optical flow. Similarly, precision landing. I've seen a lot of implementations out there of precision landing using April tags. So I built another one, fully open source, of course, which also uses the downward-facing camera gimbal. And automatic image and video upload to the cloud. I've also got another extension for that. And by the way, all these links on my slides here, I'll provide the slides afterwards, but you can go and have a look at the code that I've written there and steal it if you like. So coming soon, robust live video. So live video does work in BlueOS. It's not completely stable in my opinion. So I've been working with the BlueOS team to improve that. But yeah, it should be ready quite soon, and we will show off what we've got later today. I'd also like to be able to upload logs to the cloud, so that after you do a flight, they go up into the cloud, so you've got a permanent record. Visual follow me. We've actually got quite a backlog of Python scripts that have been written over the years, especially by GSOC students. So Asif Khan wrote a visual follow me Python script for one of his projects, one of his summer projects. So I'm aiming to turn that into a BlueOS extension as well. And finally, NVIDIA Orin support. So sometimes if you want to do really, everybody knows it, right? A Raspberry Pi is not bad at image processing, but sometimes you need something more powerful. So an NVIDIA support would be great. Okay, cool. So I'm just going to dive in a little bit more deeply into the high altitude optical flow feature that I added. So normally when we do optical flow, we use a downward facing LiDAR and a small optical flow sensor like the HERE flow, which is directly connected to the frame of the vehicle. And I think this is a great example of where we can do it better with BlueOS and a aerial photography camera. Because the regular optical flow sensor is fixed to the body of the frame or of the drone, it means that as the frame rotates, it's generating all kinds of flow sensor values, right? And we have to be very careful to subtract those. So we have to look at the rotation of the vehicle, estimate how much flow we would, what flow values we would get based on that rotation, and we have to subtract that from the optical flow sensor values. And the timing has to be very, very precise. And as the vehicle goes higher and higher, that the movement, the actual movement of the vehicle, because as it gets further away from the ground, the actual movement of the vehicle becomes a very small number. And so that basically it limits how high we can use optical flow, because there's basically so much noise coming from the movement of the vehicle. So yeah, being able to use a very high quality image from the aerial photography camera, and also, because the camera gimbal is on a gimbal, all that noise goes away. Suddenly, optical flow works at a much higher altitude than it did previously. In my tests, the limits have always been more like 20 to 30 meters maximum. But with this setup, I've already achieved 100 meters, and maybe even higher is possible. So, also, one last point I didn't make was that because we have a more powerful CPU in the form of the Raspberry Pi CPU, that's much more powerful than the little optical flow sensor. So it can use more points. And also, we have full control over the algorithm. So optical flow normally doesn't work perhaps if the vehicle is yawing a lot. We can enhance the algorithm to work better. So here's a little video taken in my hometown. It's quite a simple video, but this is all non-GPS. The GPS is not on for any part of this flight. And I created a mission. It flies first to 20 meters, and it flies forward about 60 or 70 meters and climbs 100 meters. This is all in auto mode. It goes, up it goes. I mean, basically nothing goes wrong. It does the whole flight using only optical flow. There is some drift. It goes out of the range of the LiDAR. So we've enhanced the EKF a little bit so that when it goes out of the range of the LiDAR, it will fall back to using the terrain database. So there's a little, that's not 100% accurate. Also, it's just a flow, the flow algorithm itself just leads to drift. There's no absolute position from it. Yes, Tim. What's the range of the LiDAR? Sorry, okay, yeah, so the question is, what's the range of the LiDAR? I am using, what is it, the TF20L, which is about 20 meters, maybe 22 meters. So it's well out of the range. There is some drift. So if you look closely, you can see down here, the drone thinks that it's about here when it's actually here. So, we are getting, 5 to 10 meters of drift over this 2-meter flight. But if you look really closely, you actually see that most of that drift occurs during the takeoff. So immediately after takeoff, you can see it moves on the map. And that's probably because, at very low altitudes, any kind of error turns into quite a large drift. So, I think if we only activated the optical flow when it was high up, it would actually drift a lot less. And I'm hoping to show that in a demo later. Okay, I think I'm a little low on time. So yeah, if you're interested in getting involved, there's a couple of ways you could help us all out. I am at the point where I've built this pretty good frame, I think, and I'm considering about how I could produce at least 200 of them. So, any advice you have on, frame materials, design, motors, propellers, whatever, companion computers, I'd really appreciate back at all. If you're a core developer at ArduPilot, I'd love to send you one. Only ask for it if you're really going to use it, though. If you're a hardware manufacturer, especially a camera gimbal manufacturer, we really need small camera gimbals. If you look at a DJI, their camera gimbals are tiny and fantastic. We'd really like smaller camera gimbals. And also, would really like to be able to control the image quality and the frame rate more. So this, yeah, you know, a lot of these camera gimbals give you some control, but they're basically built for use with a HearLink or a similar system. They don't let you reduce the frame rate to really low value. So a little more control would be nice. So another question from Tim?
Very nice product, Randy. Hey, just wondering, how fast can that drone fly?
I don't know. It has only flown for less than 5 minutes. So we're gonna double the flight time during this conference, I hope.
Let's test that out there. I'm really
Sure.
interested. Can it keep up with a plane?
I don't know. Maybe. I don't know.
Maybe. Okay.
I mean, I guess it should be able to do 20 meters per second, but I really don't know. I'm just pulling that out of the air. Okay, also, if you are an autopilot manufacturer, more Ethernet-enabled autopilots, please. We've got a few, but more would be better. If you're a software developer or a beta tester, if you could please consider trying BlueOS. Maybe make an extension of your own. I've got some links here to some great BlueOS documentation which shows how to build an extension. Also, of course, please feel free to steal my extension and use it as the base for your development. I also think, though, that BlueOS would benefit from just having more people test it out and then report issues. Maybe you can fix those issues yourself. It's all open source. Maybe you just report them. But let's have a run at BlueOS and try and uncover every issue we can and make it really, really robust. If you're like a drone service provider, maybe consider adopting this hardware and software stack. I think the more people use sort of consolidated or similar hardware and software setups, the more we can sort of share and reduce our development efforts. Okay, that's it. I just want to, finally thank a bunch of people who helped me out. A ton of people helped me out. So Huibin helped me out over and over again with the ESCs and the BMS. William here, of course, helped me with BlueOS. Sanket for the optical flow. Sid helped me out a ton with the Cube node, and also my main sponsor Eames, who lets me work on all these cool projects. QPilot, of course. Drone Japan, who did a presentation. They run the drone school. They were actually the inspiration, I think, for this project. Running Electronics, who did the carrier board, and then Foxtex and FX Robot, they gave me free hardware, so thank you very much. And now I will, if there's no more questions, sorry, one from Ryan.
Yeah, I was just curious, as far as using the imagery data on the companion computer, what do you see would be useful for most people buying this kind of vehicle, as far as capabilities?
Sorry, I couldn't quite hear that, actually.
What capability would you plan to add on the companion computer to use the imagery data that would be most beneficial, you think, given your experience with the users?
Well, I mean, I guess it's a middle market aerial photography copter. So most people just want to have, take videos, take pictures, and have them readily available, as soon as they land. So I think we already have that to some extent, but making that really smooth, supporting lots of different cloud services. So for example, Google Cloud, or I don't know, some other picture server that's already available. I think adding support for that would be really great.
Thank you.
Is there any question here?
Thanks for the interesting talk. You talked about OTA updates for the computer itself, the BlueOS. Have you got as far as doing OTA updates for the Cube and for the peripherals?
Cool. Yeah, thanks very much for asking. Yeah, so you might, people who follow my YouTube channel very closely might have noticed that about 6 months ago, I did a video showing how to update the Cube's firmware from the SD card. So we should already be able to make an extension in BlueOS that just forwards, that goes off to the RGPilot server, grabs a bin file, MAV FTPs that over to the SD card of the Cube, and then reboots the Cube, and that should update the firmware. So it should already be possible. It's just a little bit of programming. I think we actually should make an extension which handles all of the hardware on the drone in one page. So you push a button, or maybe you don't push any button. Maybe you push one button, and then it goes through and makes sure that your AM32 ESCs are updated, Cube is updated, BlueOS is updated, all your extensions are updated. Make it really easy.
Thank you.
Just one in the middle there.
Would you want to limit how much customization you can do with it if you were giving it to other people, or would you lock down to them only being able to change a few things?
Great question. Yes. So how much should we lock down the drone? I think, it's a balance, and you probably want to make it maybe it really depends on your use case. I've got an item on my to-do list to make another video showing people how to lock down all the parameters in ArduPilot, because Peter Barker has done some great work with a Lua script, which allows you to very carefully and precisely lock down just some parameters and not others. So I'd like to incorporate that somehow, but haven't quite got there yet. How are we doing on time?
Half an hour in.
Half an hour in. Okay, so we can do one more. Can we do Eric at the back there from Modal AI?
Thanks, Randy. Just wondering on the high altitude optic flow, is that the same camera that's also doing your main video, or do you have a separate camera that's doing on a gimbal specifically for that? And sort of a related question, is the downward facing LiDAR also on the gimbal, or is that just mounted directly on the frame?
So, okay, yeah, thanks. So it just uses the regular aerial photography camera for the high altitude optical flow. So no extra weight, just a little bit of extra programming, a little bit of extra software, that's all. And yeah, for the LiDAR, it's got the downward facing LiDAR, but that's only 20 meters. So beyond that, it uses the terrain database. It's built into ArduPilot. So yeah, it just falls back to the terrain. Answer your question? Yeah. Okay, and just one last one right here.
You mentioned you suffered a little bit with the live video.
Yes.
Frame rate, resolution. Can you talk about all the pain points?
I think the BlueOS guys know better. I think there's just a lot of different. I don't know. I think William, you should answer.
So the question is about why changing resolution and bitrate. Is that it?
I think it's just why was live video so difficult? Why is live video so difficult to get working?
I think the main issue is the actual bandwidth we have available. The available bandwidth can change if you're using, let's say, a HearLink or an LTE modem. And if you don't have control over it, you just can't get the whole video through the link. And then you start losing packets and the video freezes.
On the RPi, what did you use? How did you handle it?
Yeah, we don't have quite a good solution yet. So that's why we are looking for cameras that allow actually controlling the bitrate. In BlueOS, we use Cockpit. Cockpit uses WebRTC. WebRTC is a technology that has the infrastructure to do bitrate adjustments in real time to fit the available bandwidth. But it's not convenient to do it on a Raspberry Pi, for example, because you have higher latency and a lot of CPU usage.
Exactly.
The Raspberry Pi 5, for example, doesn't actually have a hardware encoder, so it has to do it on the CPU.
Yeah, but it's also just wasteful, right? It's wasteful to basically take the output of the camera, downsample it or whatever you want to say, reduce the resolution, reduce the frame rate, and then send it along. The camera had to encode it all itself. So you're basically doing it twice. So you're adding lag. And one of the things that people get upset about is lag in your video, right? Get the cameras to do it, as we need it, right from the beginning. It would just be so much better. So I think at this point, I should hand over to William.
Yeah. Sounds good. Okay. So just give you a BlueOS update since last year. I am William Galvani. I am a software engineer with Blue Robotics and the Ardu sub maintainer. So I'll start with a quick refresher, just why we started working on BlueOS, what were our goals, and maybe do a demo if the demo gods allow me. Then I'll I'll tell you what's new, what we're currently working on, and what are our future plans. And then you can try it yourself as well. So why? Originally, we had companion software that was forked from ArduPilot's companion a while ago. It was in 2015. It was based on Node. It was a monolithic project, and it was designed for a single application, which was our Blue Ruby. An integrator's ecosystem was not a thought at the time at all. And it was deployed as a Raspberry Pi image, and the updates were basically Git pulls. So it was with bare bones. So that resulted in some flaky software updates. It was difficult to support more accessories. If an integrator wanted to change the code, they had to fork, and then that broke the updates through Git because it could cause conflicts, and basically the integrator had to keep their fork up to date. Being a monolith, the development was also hard, and performance of some services was also not great. And you basically could do no customizations there unless you forked and everything else. So what were we looking for? We wanted something highly modular and extensible. That was critical. We wanted easy and reliable software updates. We wanted a web-based dynamic UI, and we wanted to build it with modern technologies. We wanted to support any Mavlink vehicle, and our initial target was the Raspberry Pi, but we always kept in mind we wanted to support additional hardware. So BlueOS is our answer to all these things. It's basically an embedded ecosystem that we built on top of Linux. So in order to achieve the modular, easy to update, and extensible system, we picked Docker. We have two base containers. We have our core, which has all the services in it and has the basic functionality. And then we have Bootstrap, which is a startup / watchdog system. If it notices anything is wrong in core, it reverts it to a non-good version. So it's hard to actually break the system. We were looking for a low entry barrier and learning curve. So most of our services are quite isolated. So it should be easy to look at their code and understand what's going on. Most of them are written in Python with using Fast API, and that also gives you Swagger API with all endpoints well described. You can easily play with the APIs and understand what's going on. We wanted to keep it compatible with as many services as possible, so we needed Mavlink communication. The Docker images, they help integrating everything. In order to resolve the performance issues, some of our critical and our performance sensitives are now written in Rust. That includes now Mavlink server, which is our router-ish. Ish because it works mostly like Mav P2P. There's no actual routing in there. Camera Manager is also all Rust due to, again, performances. And that leaves us some red room for user extensions and other functionality. On the customization part, it's quite easy for integrators to extend the system. We allow a range of UI changes. You can just add your own CSS easily by dropping files in the right places. So no change required at all. The vehicle 3D models are also just dropped in the right place. So in order to work with it, you can basically just fork it. The infrastructure you need is just a Docker Hub account, and a GitHub account would be helpful too. Once you fork it, BlueOS will start fetching updates from your fork, but you can easily switch between both of them just by typing down on the UI your remote URL. I have a feeling that The demo might not work. Nope. Rafael? For the end. Echo? Okay, let's leave it for the end. So what's new? Since the last year, we had 647 commits, including 31 releases in beta plus stable. We worked a lot on expanding hardware support and fixing bugs. We're also working a lot on networking support. Right now, we do support 2 network backends. That's Network Manager, and then just, what's the other one? Yeah, we're trying to support multiple host systems. That means we have to interface with the underlying network manager. And we're also making the extension system more versatile. So what's new? On camera and video, we now support H.265 video. That should work easily on QGround control. We also support it on WebRTC, but the browser support on WebRTC is spotty. If I recall correctly, Safari is the only one that actually supports H.265 on WebRTC. We have additional camera configuration and gimbal setup on BlueS, better UIs to doing that. And Mavic Camera Manager is being heavily worked on to support additional features. We recently got OnVIF support there for automatic video stream discovery, and it can also now configure the video streams using the OnVIF interface. So we can change brightness and all these little things. Another interesting thing, we're working a bit on safety. So now BlueS lets you know if the vehicle is armed. It warns you if what you're trying to do is dangerous. You can still go through, but we are warning you that you probably shouldn't. This is a new interface for setting up the gimbals. Right now, it's mostly for servo gimbals, but we want to keep on expanding it. Our compass setup/diagnostics view now includes more data sources, so it can now show you the GPS heading as well. So here you can see the heading from each individual compass plus the EKF plus the GPS heading. We are slowly filling up the vehicle frames in 3D. Copters are going soon, but there are so many copter frames, it's not quite as fun to do. We have a new helper for setting the HRS orientation, so you can visually see what it looks like, because we all know that enum is not very helpful. On network connectivity, we now can show you if each interface has an internet access. The green globe means it has internet access. If you have multiple interfaces with internet access, you can change the priority by just dragging it up and down. So if you have a backup for G-Link, you can just move it down, and it will only be used if your primary is not available. We now have an API for setting up the IP routes as well, if you need. And we now use a backup DHCP server by default. So if your PI doesn't get a dynamic IP through DHCP, it will just start its own. So if you have IP cameras and other things connected, they can still get an IP. And I guess most important for this talk, we got Ethernet-based flight controller support on Randy's request.
Thank you very much.
On Mavic routing, we are now using Mavic Server. It has been heavily worked on recently by our Rust engineers. It's insanely efficient, very fast, and it has a great diagnostics interface. You can plot basically any data you see. You can you have a list of all the vehicles and components, and it supports all the regular Mavlink endpoints. I mean, Mavlink protocols. Well, transports like UDP, TCP, serial, and WebSocket. The WebSocket API is right now compatible with Mavlink to REST. I don't think we have a raw Mavlink over WebSocket yet. We have been working also on the extensions ecosystem. It's growing. Randy wrote two new ones. I myself have been playing with visual odometry and what's the other one?
The OT cameras, right?
Yeah, I'm working on integrating visual odometry with OKD cameras, which is fun. We now also have some new extra fields in the registration API. And so you can just add additional data there, and we are using that to expose widgets to Cockpit or actions to Cockpit. So in this example, for example, we have a Sonar extension that exposes a Sonar widget to Cockpit. So you can, when you open Cockpit, the widget's there. You have a note, hey, I found this, and then you can just add it to the UI, and you have your Sonar integrated with Cockpit. Same thing you could do with camera actions on a camera extension. So you can just have camera controls being exposed to Cockpit. And more. We are working on a new dashboard UI on the homepage, so you have a digital twin there. This is still very initial phase. We're going to work on it a lot more. We have been working heavily on bug fixes, so please report everything weird you see. And we are also working on supporting basically all of the serial boards on our pilot. Okay, so what's coming next? We are working hardly on integrating Zeno there. Zeno is a pub-sub communication bus. I think ROS 2 is moving to it, right, Ryan? This is interesting because it allows you to have a synchronized log with all services and video and autopilot data. So you can basically have a snapshot of the whole system at a given time if anything goes wrong. We are also looking forward to migrating our front ends to using Zeno because right now we rely a lot on HTTP requests, which could not be the most efficient transport media. We already have on the front end, we can show the Zeno network. So you can see all the services there, and if there's a computer connected, you can also see our computer connected, everything in the network will show here. Another thing we're working on is MCAP. So all this Zeno communication will be stored into a MCAP file, which is what I said on the previous slide. This is how we can replay and understand the whole system at once, at a given timestamp. We have been working on ROS integration. I guess I myself personally I haven't been very friendly with ROS, but I'm giving it a chance now that I managed to Dockerize it. So that's another place where the BlueOS extension system helps a lot. Another exciting thing is we're working on Foxglove integration. Foxglove is a very nice application to visualizing data.
Yeah. Sorry, quick question back to the previous slide. And maybe I should know, and hopefully it helps other people. I don't know what MCAP is.
Oh. Do any of you two want to answer? Because they will have a more complete answer.
If you've used ROSBAG, it's a better format than ROSBAG where it includes your message definitions. It's essentially like a bin log, but it works with large amount of data, including like LiDAR and camera data.
Yeah, but now you have to answer what's a ROSBAG.
Well, it's like an ArcticPilot bin log, but for large amounts of data. It's very efficient for, if you're collecting a gigabyte every minute, and to be able to search data and run transforms on that.
Yeah, it's basically a ROS standard for logging data. Okay. Oh yeah, and here we will include the videos, so we can replay the videos also with everything. In Foxglove, you can have the whole vehicle attitude. Well, the map's not as easy because we don't have enough resolution, but if you have a LiDAR. Other things we're working on, well, we're planning on. We need better resource management and tracking, including CPU usage, memory usage, I/O. And after that, using that, we want to make a better notification system so we can actually let users know if anything is, let's say, out of bounds, anything unexpected is happening. And that will also include online backends, so we can notify of critical updates, version changes, and safety issues. Another thing we're looking forward to is getting a better service management. Right now, you can disable individual services, but you have to do so through environment variables. So we want to set up an UI for that allows you to stop, enable, disable, restart individual services. We also want to separate them into different containers. Oh, it's back. Yeah. But we still want to use the same image, just different containers. And we also want to add previews in the dashboard on the first page for these services and extensions. So yeah, you can try it yourself. It's compatible with a lot of hardware, including x86 computers with Docker Compose. You can just try it with this command line. You can also find it on our GitHub, so bluerobotics/blueS. We're slowly growing in popularity. It has been used extensively on ROVs and boats. It had some use on drones, not a lot so far. And we would love some more people to use it and give us feedback, and we are willing to assist you if you want to integrate a new hardware or vehicle. You can download it here. Yeah, so I just want to thank you, the ArcticPilot community, for everything, and go ahead.
Planes, fixed wing, VTOL. Where is that on the plan?
It's hanging on my wall right now.
Hey,
I have a VTOL hanging on my wall.
okay, not much good, but okay. Let me know how I can help.
Oh yeah, definitely. I think right now I just need a better battery.
I think it'll basically work.
Yeah.
Any ArcticPilot vehicle will basically work, but there's little details that won't work. Like the mission command list will be way too short. Like Copter doesn't have a takeoff command yet in cockpit. So there's like some basic stuff that we need to fix, but it's also easy to fix.
Okay, just want to thank ArcticPilot for the great team and project, Blue Robotics for actually embracing open source, and Elliot and Patrick for helping with the slides. And now let's try that live demo. It's going to be quick. Let's start with cockpit. Do we have? Oh, there we go. So can you show me? Yeah, so that's our running blueS. That's probably me waving at the stage. All of these black spots are hit transmit requests on WebRTC, so you can see that the network is not quite happy.
But it's not bad. Not bad.
Yeah, I see. Now it lost Mavlink connection. How? Oh, there we go. Okay. Oh, it's gone. I know, I just switched pages. That's fine. We have 5 minutes, so yeah, just go take a brief walk through the UI here, if the Wi-Fi allows me. We have some autopilot management. You can, yeah, it's not allowing me. But yeah, this is what it looks like. I think that's plenty. You can try it yourself. I think he's gonna show me I have to finish now. Yeah. So yeah, that's it.
Final question?
Any final questions?
No? All right.
Fantastic talk, both. Thank you very much. That was excellent. Next up, we've got Lee Schofield. So we'll be starting again in 5 minutes.
Thank you for joining us for the Arduino Pilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Polybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organized by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.